We've been asked to find the equation of the tangent line to the curve defined by the parametric equations x equals 1 over t and y equals minus 2 plus the natural log of t at t equals 1. We're then supposed to find the value of the second derivative of y with respect to x at that same point. Well, to find the equation of the tangent line, I'll need the slope of the curve, dy dx, which I know I can find by dividing dy dt and dx dt. I'll also need a point on the curve at t equals 1, and that's what my original parametric equations will do. So let's start by finding dy dt and dx dt. So let's see, dx dt. I'm thinking about 1 over t in my head as t to the minus first, so its derivative minus 1 over t squared, minus 1 times t to the minus second. dy dt. Well, as I differentiate from left to right, I have 0 plus 1 over t. All right, so dy dt, 1 over t divided by minus 1 over t squared. And let's see, I have 1 over t times minus t squared over 1 is just minus t. Evaluating at 1, I find that the slope must actually be minus 1. All right, now I need a ordered pair, so I plug t equals 1 in to find x, and I plug t equals 1 into the formula for y to find y, and I get a minus 2. So the point on the curve is 1 comma minus 2. Now I just need to find the equation of the tangent line. I'm going to use point slope form to do it. Let's see, I'll have y plus 2 is equal to the slope times x minus 1. Oh, let's put that in slope-intercept form. I get y equals minus x minus 1. So there is the equation of the tangent line at the point requested. Now I've graphed the function already because I was curious about what this set of parametric equations graphed. And so it graphs this curve, right? And then I wanted to make sure this tangent line we found makes sense. So let's see if I can get that to turn on. And there it is. There's that nice happy tangent line we just found. Now all we'd need to do is find the value of the second derivative at that same value. Right there at 1 comma minus 2. Well, I can find the second derivative by differentiating y prime with respect to t and dividing by dx dt. What I always like to think about is I can think about parametric equations that would graph the derivative as x would still equal the same x, but y would now equal the value of the slope of the curve at the point. And so I have dy prime dt over dx dt. Well, it's not going to be too hard to find the derivative of dy dx or y prime. So dy prime dt is just minus 1, and I've already differentiated dx dt. So let's see, the second derivative of y with respect to x is equal to minus 1 all over minus 1 over t squared. And let's see, that's just going to be t squared. I'm supposed to evaluate this at the given value of t. So the second derivative of y with respect to x evaluated at t equals 1 is just 1. Well, if I go back to my graph, the second derivative of y with respect to x being positive here makes sense because at that point the graph is concave up. And that's all we have for now.